Okay, we're in section 9.5, distance formula, and this is a formula that you've had probably in the last 2 years in pre-alg and algebra 1, where you're looking to find the length of the segment that joins 2 points in our XY coordinate system. Or, again, I want to find the length of line segment AB, or I want to find the distance between point A and point B. So, let's give some coordinates to our points A and B, call them A comma B and W comma T. And our strategy with the distance formula is to apply the Pythagorean theorem, which if we then go ahead and create either below where I'm going, or I could have gone above as well, up in here, create a right triangle that's going to have legs, 2 legs, and our segment AB turns out to be the hypotenuse. Now, we want to label the coordinates of this point that we've created down here at the right angle of the triangle, and you'll notice that the height, the y coordinate of every point on this segment down here is going to be the same as point A's y coordinate, so we know then that that y coordinate there is B. And we note also that over here the x coordinate of every point on this vertical line is going to be the same as the x coordinate of B, so that's going to make the x coordinate over here to be W. Now what we need to do is find the lengths of the 2 legs of this right triangle formed. So let's go over here and see if we can find this length first. If we go all the way up here to B, that distance is T, and if we go up here to this point, that vertical distance is W. So if I want what's here, that's going to be T minus W. By a similar method, down here with this horizontal segment, I'm going to go all the way over here out to W, and I'm going to go to here out to A. So if I'm looking for the length of all the way out to W, take away out to A, I've got W minus A. We then want to work on that right triangle, so we've got our lengths here of T minus W and W minus A, and we want to find this length over here, AB. And to do that, we simply are going to use our Pythagorean theorem. So we say that AB squared equals W minus A squared plus T minus W squared. And therefore, AB is going to be the square root of W minus A squared plus T minus W squared. And if I then go back up and look at my original setup, what about W minus A? W minus A turns out to be subtracting the x coordinates, and T minus W turns out to be subtracting the y coordinates of our original points A and B. And you might wonder, well, what about the order? Is the order going to matter in the subtraction? Well, think about it. What does W minus A squared, how does that compare to A minus W squared? For example, 2 minus 4 squared or 4 minus 2 squared. Same thing. Ditto for T minus W or W minus T. If I square those differences, I'm going to get the same thing. So basically, the formula is subtract your x coordinates, square them, subtract your y coordinates and square them, add them together, then take your square root, and that's your distance formula. So we'll look at that at one more as just the formula itself as we keep going here. So suppose we want to find the length of segment WR. we've got our x and y coordinates, and we then know that our distance formula says that I'm going to look at the difference of x's, that would be m minus f or f minus m squared, plus the difference of y coordinates, that would be h minus o or o minus h squared. Take the square root, and that gives you your distance between 2 points in the xy coordinate system. So one example here, suppose I want to find the length of segment TV. Coordinates of t are negative 7, 20, and the coordinates of v are 13, negative 5. So if I set up my distance formula, it's going to be the square root of difference of x coordinates would be 13 minus 7 quantity squared plus difference of y's 20 minus 5 quantity squared. 13 minus 7 would be 20 squared plus 20 minus 5 would be 25 squared. Now I want to look at that 20 squared plus 25 squared. If I go ahead and do the arithmetic as is, I'm going to get just a huge number. But do I have a common factor that I can work with in this radical expression? The answer is yes. If I take a 5 squared out of each of the two terms, that's going to leave me a 4 squared plus 5 squared here. Note that if I multiply through my 5 squared, I'm going to get 20 squared. And if I multiply my 5 squared through to the 5 squared, I'm going to get 25 squared. So to keep simplifying then, that square root, and note I'm multiplying here under the radical. I am multiplying 5 squared times something else. So I can go ahead and take the square root of that 5 squared, that's going to come out front, and I'm left with a 4 squared plus 5 squared. No common factors between the 4 squared and the 5 squared, so 16 plus 25 is going to give me 41. So my length of that segment is 5 root 41.